Hi guys, this is me, Artie, and this is a new edition of my video blog for geeks, nerds, and, all people generally interested in science and stuff. What do we know about the human eye? What do we know about its history? For example, did you know that back in the day people couldn't see the color blue, like here? Or how can we tell if your red is the same as my red? Or did you know that there are people who can hear colors and see sounds? The human eye is an organ so complex that back in the 19th century, Charles Darwin believed that the idea of it being evolved seemed absurd in the highest degree. Yet, it may not seem so absurd if we consider how long it actually took for it to develop. Evolution of the human eye started 500 million years ago with a light spot in one-celled organisms called euglena. It activates when it finds light and, therefore, food. We can find a more complex version of that light spot in a flatworm called planaria. It's cupped rather than flat, which helps it sense the direction of incoming light. Not only does it help find light, but also shade, which is really useful when you need to hide from predators. These light cups grew deeper in some organisms, and the opening at the front grew smaller. The result was the pinhole effect, which increased resolution and reduced distortion by only allowing a thin beam of light into the eye. One key element of the eye as we know it is the lens. The lens is responsible for the eye's adaptability, letting it change its curvature from near objects to faraway objects, like looking up for your phone and focusing on birds in the sky. That pinhole construction combined with the lens serve as the basis for something that would eventually evolve into the human eye. It may now seem like an example of the perfect structure or intelligent design. However, it's far from being truth. We do have color vision, but some birds and insects have a more balanced version. We don't have tatum lucidum, which gives many predators night vision. And we can't see motion at the same resolution as dogs can. Those may not sound so concerning though. Well, we don't need to see the ultraviolet spectrum and we don't need the ability to spot prey from faraway distances. However, there's that darn blind spot. Yes, you may have already heard of it. There's an area the size of a coin 3 feet away from our eyes that we can see. That's why it is sometimes very hard to concentrate on close-up work. Things like myopia, nearsightedness, can serve as a good example. It's not caused by injuries or extensive usage of the eye as many people believe. It's just bad design. If you add to the list farsightedness, glaucoma, and retinal detachment, you can see that the human eye is far away from being called the perfect design, especially if you compare it to the visual organs of many animals. Human vision is a very complex phenomenon that isn't limited to only our eyes. However, it comes so natural to us that we don't really pay attention to what's going on behind it. In fact, it takes a third of our brain to process all the photons that get in our brain to interpret them into an image of a rainbow, for example, or into an image of our mother's face. To really understand the processes behind our eyes, let's hear a story of a man who lost his sight when he was a child, but was able to return it back 40 years later. Mike May lost his sight when he was 3.5 years old to a chemical burn that destroyed his retinas. Anyway, he didn't let it stand on his way to becoming a successful businessman though. Yet, after 40 years of blindness, he found out about a way to restore his sight using stem cells. The surgery was successful from the surgical point of view, but not from Mike's. Mike's retinas could let light through and focus it properly, yet his brain couldn't process the incoming information. Nothing he saw made sense for him. For example, he could see the faces of his children, but, well, he couldn't really say what they looked like or tell them apart. Mike couldn't really call his visual sensations sight. What happened was, for about 40 years, his brain had been occupied with other senses like hearing and smell. And this affected his brain's ability to communicate signals required for sight. This example really shows us that our eyes don't really work like a video camera. It's not enough just to take the lid off the lens. Speaking of, those lenses, your eyes, I mean, aren't the only things that you need to see the world around you. Human sight is not limited to the visual cortex's interpretation of photons. To really experience the world around you, you need your whole body, which is proven and demonstrated in 1963. Richard Held and Alan Hine, researchers from MIT, conducted an experiment. They placed two kittens in a carousel with striped walls. Both kittens could perceive visual information from moving while inside the carousel. But there was a crucial difference between them. One kitten could walk freely, and the other one was placed in a basket and moved passively. Both kittens could see the same images from the moving lines, and the result was very surprising. Only the kitten who could walk freely developed properly functioning vision. So, our sight depends greatly on our motion. It also, in fact, requires strenuous physical activity. We don't really notice it because we are used to seeing the way we do. Just try on a pair of prismatic glasses, and it will become very difficult for you to navigate when everything is upside down. And what about that, is your red the same as my red? Well, while this question may raise some philosophical dilemmas, from the material point of view, this question is fairly easy to answer. How can we do it? Well, men and women do see things differently. For example, women are better at color differentiation, while men are better at noticing things from far away, which is proven by a study. There is that thing called hunter-gatherer hypothesis, and findings support it. The hypothesis states that successful hunters, men, were those who were able to see the game from a distance, and successful gatherers, women, were those who were able to distinguish between poisonous plants and non-poisonous, so they developed an ability to distinguish between colors like crimson and red, or they didn't, which didn't really end well for them. Either way, survival of the fittest dictates that successful genes have a greater likelihood of being passed on, so here we are. Now, remember that bit about hearing colors and seeing sounds? It's a thing, and that thing is called synesthesia. 4% of the general population has it, and it occurs when stimulation of one sensory pathway leads to the stimulation of another. So, people with synesthesia can hear colors and see sounds. In fact, there are many ways in which synesthesia can manifest itself. For example, grapheme color synesthesia, where every letter of the alphabet has its own color, and lexical gustatory synesthesia, where you can taste words. And those are just a couple of examples. It's believed that synesthesia has its roots in our early childhood, when our brain is first attempting to process multiple senses at the same time. Right now you can hear me and see me, and your brain needs to put those sounds of my speech and those images of me together. This relationship between our senses is called cross-modal relationship. Even though our senses are distinct, they still overlap. Take your sense of smell and taste, for example. You can't really taste something if you can smell it. And the common explanation for synesthesia is when a developing brain goes too far in mixing those senses together. Even though it's considered a neurological disorder, it might enable people to see the world in exciting new ways. Comparing synesthetes and non-synesthetes is like the difference between having sight or not. It's very hard to explain what colors are like if you can see them. You've got to be creative. One of the most powerful examples of such creativity was Alexander Scriabin in his symphonic poem Prometheus. Every note in that magnificent musical piece is associated with a particular color, and modern performances of this piece often use different lights to actually show us the color of the music that's playing. Watch it and you will feel what it's like to see sounds too. And what about you guys? Do you have synesthesia? And if you do, what kind? Can you maybe taste words, or smell images, or maybe see sounds? And if you can see sounds, tell me, what does this chord look like? And this has been me, your main man Artie. Leave a like if you liked the video, subscribe and share it with your friends. And I will see you next time.